Hello, welcome to another video. We'll go into large mode again. Just keep that way. What are we doing? Working on a new assembler project, I guess. It was it still is a new operating systems project. So what do I have? I have I thought that was the right thing. So pretty much I have this source code that I kind of want to assemble, and currently it gets up to this point here. Does not know what to do here because it hasn't seen this thing yet. So perhaps it might be time to add labels in. So in the background, I've actually done quite a lot of stuff. The test suite actually tests a lot more, and you might see that there are some functions, new things added. Gosh, it goes slow when I'm recording, and I wonder if the battery looks alright. Yeah, we've go a whole page now. So we can do like assignments, binary operators, the bits. I can't recall what that test is. But yeah, it kind of goes through. Some of them could be consolidated now that I've kind of gone for that style of just one word for it, and like all these DB things could get joined in. And I guess what I could do is have a quick peek at some of these tests. So if I just kind of cat them out, we can see it goes through a lot of things. So we can assign things that can have binary operators in it. We test like a whole range of things here. Yeah. And recently I was just kind of getting the limits in so we can do large things. But I think what it is time for is adding the labels. So to do this, you kind of need to do two things. So when you first encounter the label, so we can even, I think if I do this, yeah, I had it kind of reasonably close. We can do, our make program can be test. No, it's ASM and then test in there. So, if I do this, it kind of jumps to the right place. This is where we have our invalid identifier. So at this point here, we kind of want to, I might use this source code to kind of jump through. We can see kind of where it was done and perhaps work out what to do based on that. But basically, when we do that jump instruction, what we can do is basically put in something random. So we can, I don't know, A, B, C, D. It doesn't really matter what it is. It could even be 4 zeros. But the idea is that you have what you might call a hole. And then when you come to actually find the label that is passed in the future, we can kind of look at what the dollar or dollar, I think, can't recall which one's which. So you can look at that one and basically work out what address you are at now, and then go back through the previous history to find all the holes to then kind of fill in the blank, so to speak. So I think that could be something cool to do. So how do we go about doing that? Right, so when we basically in a, perhaps this point here, kind of show where it's printing the error, and that's kind of where it is. So what we do is we kind of look in our hash map of the current scope. So we have a scope which is a hash map that I've kind of made, and we look up the current expression, which is a label that we've kind of determined in the switch statement there. So it is an identifier type, so it should just be a string. So we can kind of look that up in the hash map, find the value. If we don't have a value, this is kind of where we want to say, actually, this is a whole. So we need to have the structure for the whole. We will also need to have some kind of way to then work out when we read the label where we need to go back to kind of say where we are. So I wonder if this is potentially easier working backwards. So say we are in the JMP, so perhaps execute JMP, this one. So in here, it's kind of like we compute the expression, and so this particular one is when we're trying to compute the computed expression, and so I guess we need some way to say at this point what byte offset are we at this current point here, and that's where it gets like a little tricky, because this is when we're actually no, it is when we're computing the expression. This does work. Cool. So I think in this point here we can return a computed expression of a whole, and we can just kind of make a new computed expression type. So I might actually have it sort of that. So if we look at the computed expression, we can just make a new run, and it will complain in all the places where this is, and we can just call it a whole, I guess. And so when we do that, we, instead of returning this error message, we will kind of return that whole, and that can probably be something pretty straightforward. So it could probably be a computed expression. So when we do this, this is returning a just a single thing. A single thing, I mean, on the stack. I might just bring that back to that. So what we need in here is we can call this computed expression, and it is a whole type, and the span can just be expression.span. And what else do we need to kind of give with that? That's perhaps all we kind of need to say about that if we can't find it. And yeah, because at this point we don't quite know where we want that whole to kind of end up. But when we yeah, it might change depending on, because like here I'm thinking I might do it in the jump part, but then you will also want that kind of whole type situation for any other expression, I guess. And it kind of, oh, that's interesting. I do some bounds checking there, but I've actually got a new function for that. So we can just, if ASM, if not ASM, check bounds of computed expression. We need a config in there as well. this is going to be an ASM, looks like a word size, and then we can just return false, and that kind of gets rid of all of that. All of that. And we also want to do that for the, where'd that min and max come from? We kind of set it up there. We can do that better. We can just have a size type thing, and then we can here we can just go size is this is going to be the word as in the word. So I've kind of got sizes now, and then this can be just a single word, and we can probably make that maybe I'll just have that, and then we can just kind of have the size there, and then this can be ASM size, data size, that's what it is. We can kind of have that like that. So that sets that, and then that means we can get rid of those bunch of lines. Easy, cool. So you kind of this is kind of like where you need to work out where the hole is going to end up, because if you have a hole, you kind of want to print as much as you can up until the point that you want to re-overwrite, which, yeah, kind of might need things changing a little. And then like here you would have another type of hole and do whatever in there. I wonder if we can do something like this. So computed hole, and we can have that be false, and we can also have a bar hole, and maybe this can be hole like that. And then we can just have hole equals true. I won't currently let me just fall through. It will be good if there was like a keyword like that, but there is not. And the errors I have will we'll complain about that, but it will also it doesn't complain about it. Interesting. If it doesn't complain about it, then perhaps I'll go with that. And then here we just need to kind of check what the var one is, and if it is that, we can have var hole. But perhaps like I need to. I think I need to like kind of break out this type of thing and almost just at the top. It makes the string builder a bit worse, but I mean we can actually allocate some space. Yeah, that might be what I do. It kind of will kind of make this the main one. So kind of at the start of can we get that EA? It was EA. Yeah, can we get this? Actually, this one, and take me back here. So kind of every jump. I should check this in the old table, but we have JMP. Yeah, so not everyone does kind of depend on it. So we kind of need to know what we have coming up. And so this far computed, it comes from far expression. No, where do you come? You surely get computed at some point. So yeah, you get computed from the far address, and kind of that gets set um, when we're parsing it. Cool. So when we parse it, we already kind of know whether we have that far address. And what I think needs to be done is like you kind of need a table for this, but what I'm thinking is that we kind of have something like this, and then we could. Um, what do we have? We do actually have just a pin chart. I wonder if it does that for me. We kind of want to do this in shore, I guess. So we would have the actually get back there. So I kind of want to get this all the way to um, there and do that. And I want to ensure at least so it's going to be at least 5 bucks, isn't it? Yeah, like really depends on like all of this stuff as well. That's just depending on which mode we are in. So where do we do the prints? It's either going to be just 2 bytes plus the file address if we have it, and if we don't have the file address, do we kind of just complain? Um, if, yeah, so we just kind of have a to do down there. So we're going to have a size instruction size, and we're going to have at least one thing, and that's going to be opcode, I guess. And then we're going to switch on the config mode, I guess, and in that config mode, we'll have we don't want to do this, do we? Yeah, so I'll do. I don't know. I'm just kind of changing just the jump. It will kind of have to end up for all the others, and it will complain in all the others when you have a computed extraction of whole. You'll be like, how do I do that? So this kind of checked if we had that. Yeah, so that is the check that we want to do. So if this is the case, then we just want to do that to do other JMP encodings, something like that, and maybe we'll something like that. And does to do should be false. I can't recall if it quits or not. So all this I kind of want to make sure is down there. And here we can have kind of two things. So if we have a ASM word, it kind of is doubling up here, but we'll have int size equals or, and if we have a D word, then we'll have 8, and these will both just break there. We'll have a default for if we got a word that we weren't expecting. Do we check it in this thing? We most likely have, because like we have all these other types of words you see, and the compiler will complain if we don't have all the cases. So we do that, we can now kind of ensure the size, and then we can kind of do it bit by bit. And here's like kind of where you can work out whether something is a whole or not. And at that point here, config output dot size is where you want to kind of save. That's where my hole is. That kind of makes sense. Ooh, so kind of want to do all this checking of stuff beforehand. I mean, that's kind of where we compute it. We check the none up there. Cool. So yeah, at this point here, we kind of know that this is a whole. And so I guess we will have some kind of thing, and this will probably be a hash map, and perhaps it's tricky to do that with the hash map thing I've done, because I kind of want a hash map with keys of your like label, and then the value is like an array. So yeah, I guess I can do that. So in here we can we already have an array, don't we? What array types do we have? We've only got these kind of array types, but we can define our own one. And do we have any that become one? No. So what we actually want is perhaps actually there's one of these built-in one, but perhaps I'll make array a bit better. So in here, can we yeah, we can do that. So in here we can perhaps also give a size T, and uh, size T is kind of like weird. No, I can't like it. Cool. So in that we can we back in here. So now we can have an array size T, and so get a pointer of this back. So this is going to give us an array. We'll get out of this polls thing, and I believe this, yeah, it just needs to take a few things. We also kind of track this error. So we will get the hmm. It's probably even better as like a linked list type thing, but array it is. The dynamic array is contiguous, but it doesn't need to be contiguous. Linked list is potentially better, especially because I control the memory, but it is what it is. So this key, what key are we going to give? So the key that we need to give is going to be the current. I think we need to do something kind of spooky like this and kind of cast a like the current size to an int pointer to avoid star. And then we will track whether we got an error. And so if we didn't have an array, why does hashmap get actually hashmap? So why does it get actually have an error? It only really has an error if we I suppose it's in the case that the thing you get is null. You don't actually know whether that is the case, but in this, you can do it. In this, we kind of know it, and not that one. Yeah, this one. So if not array, or we had the error set for some reason, we can kind of create an array, I guess. So we can allocate and we'll pass in the pool. And currently the allocate just ships out to malloc, just so you get the ASAM reports back. But yeah, so if we allocate and we want to get the size of array size T, maybe we can probably even do something like that. And if we do that, and then here, if we still don't have it, then we can memory, we can get that one and kind of yank that there. Otherwise, we have an array, we get it, but we should probably also now hash map put config pose that spooky thing. Link tool there, thanks, and then find that, yeah, and do that, and we want to put in our array that we just got, and guess we will track the error, and if we had an error at this point, I believe it's basically the memory allocation error as well. At this point here, we should have an array pointer to valid an array, but it might not have anything in it. But what we want to do at this point This isn't actually what I want to do. I want to get. This is going to be head of computed expression.span. Spooky. But we'll take a into to it. I think that's what I want to get. So yank tool there, and we can search for there, and V tool there. I'll place it with that. Yeah, because if we have a whole, the whole should be the label name as a string, the whole span. So we just get that, and then we have an array of size t's, and now this array we can go array append, array append, and we have a pool we have to pass through. We have our array, and we have our value, which is just config output dot size, and it's the current size of where we are. And then I think we just need to kind of token append however many bytes that we need to kind of say. Now that makes me wonder, because we have a whole, we need to know how big the hole actually is that we need to kind of fill up. So I guess this actually needs to be an like array of a tuple type thing. So perhaps here I'll type def. So what if we not there? Get this. So if we type def struct, so in this we need a size t location, and we also need an ASM data size t of a size, and this is going to be our ASM whole t, and then we can also type def an array. Is that kind of how we do it? Array, yeah. So we kind of do something like this. An ASM whole t, and then we have an array of holes. And then here we, instead of array size, we get array ASM array quality of our arrays, and because I did this size of dereference of array, we don't actually need to change the size of there. It's one of the reasons why I did that. So you would change. So this gets a last. So I think because we're single threaded-ish, I mean signals can still fire and whatnot, but we don't do anything on them. So we don't really care what was in there because we know nothing was in there, so we'll just overwrite it. And then we will need to, does that mean we need to kind of have, no, we can array append, ASM whole t of, and this will be a location equals that, and then we will also pass in a size equals, and we have a size kind of spared out, I believe. And then we just do that. And we will want to do something there. We will now want to break. So when we so I don't want to call this size a data size. So can search for it, and then do something like this. That one there, and then we can have that. And so here, when we do this, our whole could just be however many bytes it is. But yeah, we can do switch on the data size, and based on the data size, we will print out however many things we are. Except I think I want to do like a ASM output. Output bytes, and like we can pass it the perhaps just the config, because it will need the pool and whatnot, as well as everything, and then we can just pass in, we just want to put a 0, and we can pass in the data size that we kind of want to output as. And I think that so if we perhaps look for that, here we can perhaps we'll make it return that. So then we can do something like this. So output bytes, and then we would have something like that, and then we'd also have long number, and then we'd also have ASM data size T, data size. So in this is where we would do the however it is up here. So we'll do something like this, depending on what size it is. So if we have kind of interesting that we because we could just switch on the size, not the mode. So switch on this data size, and we have a dot star num data sizes. This thing here, well, in fact, like that thing there, and then we can do that. And then if we have a case byte, so we could have ASM byte. If we have a byte, we will just do string builder pinned just char, I guess. And then we can pass in the config. So here we if not config, we can return false. And here we can pass in the pool, we can pass in the output, and we want to append the character, the number mod 0, that, and not mod. And then we just do that. And this, I guess we can return this equals 1. Yeah, we'll do something like that. And then here we can add in our word, and then when we do this append format, actually I kind of like this. No, I changed my mind. So if we do this, we can append a format, and the format is going to be 2 characters, and then the 2 characters we will return that, and we can also have number shift 8 and mod FF, and that's kind of doing it a bit different. So maybe I'll do that, and like I wonder if it will yeah, put it in a like nicer place. So here we can perhaps just do that so we can kind of see, and I kind of want to make it consistent, even though it's potentially a bit more effort. So we have that, we do that, and there's more stuff that we could do, but that's that. And then here we can, this can just be unreachable, and we don't need to return anything. Cool. So in this, we'll execute the jump. So if we have this, I think this we can say this is unreachable at that point there. Just because we are not there, but we checked it up at this point here. At this point here. We might need to do a different thing, but this is kind of hard coding the 0xe here, which it is what it is. So I think at this point here, if we have this, in fact, yeah, I kind of like this. Now we can do just something like if not ASM, I kind of do that. We can pass in the config. We can pass in just this expression dot number, and we can pass in the size that it's meant to be, and that's data size, I guess, and then false. And then like all of this, it's kind of related to the file address, if that kind of makes sense. So I kind of think I'll just put it here. And then this kind of naturally comes back a couple. Then we just break out of that. We do this. Feels like things could still be yoinked back one more. So we kind of print out the this is the wrong wording, but we'll change that out to that sort of thing. Cool. So we do that, we have that, and then in this we have a very similar type of thing actually. So I might actually just yoink it. Yeah, because we don't need like any of those checks anymore. So I feel like yoink. There was a yoink noise, and I'll kind of just put in the hole. And here, when we do that, we do the computed number instead. And at this point here, I think we want to return true ourselves. But perhaps I had like a expected we had something like this. So I wonder if I do something like that, and in that function where I got it, what did we do? We kind of did something like that. And here we can do the same thing. So expected we'll just go up by instruction size, I guess, which we kind of work out here. So expected plus equal instruction size. Then we don't need that, so we just do this, check for a hole, this, check for a hole, and do that. I feel like that might do a thing. It's got a lot of things because it now knows that there is a hole, and we don't care about anything in the union for a hole. Here, where we're freeing stuff, there's nothing in the union, so there's nothing to free for us. If we're computing it to taking a normal expression to a computed expression, there's no equivalent in expression, so there's nothing we would do. If we're computing a unary, so we will get an error here. And I'm kind of happy with just an error. Maybe. Perhaps I can computed type. Maybe we can do this, and then this is a whole. We can just do unreachable, and in fact, maybe we'll do to do instead. So we'll get the error, but we'll also get a little to do that we need to do something. That's what to dos are all about. Right, so what are we meant to be returning from this? I thought we're, well, that first off, this is quite annoying that it's like that, but it's because we don't have a T, and we don't have a D. Cool. Do we... this will kind of complain about the hole when we get a hole, and this will also complain about the hole when we get a hole. This should also complain. Perfect. This will also, so like when you put it in the switch, that means there'll be basically some check for the default here, and I have this. Perhaps I could put that in a little macro somewhere to save a few lines, but now we're getting a new thing, and I think I know why. So when we're output bytes, when we do this, we want to actually kind of convert this to an unsigned char. And I wonder if this will let me do something like that, and do something like that, and there, and here we can unsigned that, and then here we can also do that. And I wonder if this will let you do like higher than 127. Too few things to ensure. Cool. So what is there in builder? In this we have ensure. We also pass in the file and the line. It's a little kind of interesting, but there's reasons for it. Cool. So if we do this again, we got another, and we actually deal with the whole. We don't have anything in there. So if we struct ASM config, no. can we go config t that, config that? Yeah, so in here we want another hash map, and this is going to be our holes. Now, when we, well, actually, yeah, we will want to do something like this, but with holes and also holes there. And when we get the scope, we actually check what type of thing it is. So we are going from a string view, aren't we? So I think we're good to go with just saying that is going to be our hole. So this can be computed, expression.span. We can deal with that in a bit because I've got this just burning in my thing. So it requires another thing. The pull, the thing, the pull, the thing, the key, the value. The pool, we're not passing the pool. Config pool. It's interesting because the compiler, it just checks, oh, you've only got 4, but if it did the first basic check of, oh, this first argument doesn't look right, or the second argument doesn't look right, then like it would put the cursor in a better place. Basically, exactly where the error is, but I get why. So array append, we passed in too many. That's because we kind of need to wrap that whole thing in that. Yes, I most likely did, and wherever we did it, we just need to do that. We deal with the hole there, but it's also in a switch, so it will kind of complain in the right way. This will have this thing kind of issue. This just needed the array to be dereferenced. Getting closer. It also required this to be, oh, can we do that? Except we can. What was the answer to my question? Now we just have those two whole things that we don't care about. Now this works, cool. And we straight away on this. Interesting. So if we get here, I think I actually want to do we just have that? And like, can we just do that to other JMP encodings? Because I am quite confused as to why it thinks we need a different one. Yeah, it thinks we need a different one at this point here. Interesting. Right, so this needs to be an equal. Classic. Nothing would have worked. So now we haven't handled this thing, and that is when we're huh. Oh no, this isn't the right thing. We want to if dot star num modes, we want this bunch of things. but maybe we want this to be data size because it kind of looks like we are going over there. Now we get an unreachable at this point, so I think if it's equal, yeah, because we should have checked that before. Cool. We get bad free. Ah, interesting. But yeah, we can't execute a thing. I think I might respawn things. That is because in the config we do a for each, and we don't want to read the data in our holes. It doesn't really make sense. So if we do that, oh, we still get that. Now that is kind of interesting. Is it even in that point? I'll see if I get that here. I do get that here, and we're saying that the key is not valid. Now, this when we get the hash map get, we actually want to do a hash map put as well there. Can we? I want to do that and that type of thing. Except I want to go the other way. Just like changing things around. So when we do this hash map put, we're actually just putting an address to a thing that is in the current scope, which once this gets out, it will kind of go away. So we actually need to do a string view the span. No, we do that way around. And we need to allocate a pool of size of span. So we need to do that, and if not span, we would have some type of error. Otherwise, we would then just do span equals computed expression dot span, and it will just kind of take the same thing, and then we can change this to be span. Now we want to free that. So for each, and this. Oh, yeah. So this the data is actually an array. So inside of this gnarly thing, which is a bit voodoo-y because it seems like it's just a parameter to a function, but we're just putting code. That's just how it is. But in here we have an ASM array of holes. Yeah, and this is going to be what the data actually is. And then we want to do an array free, and we need to pass in the pool, I guess, and then we pass in the array as well. Probably like that, right? And then we kind of clear that, and then that doesn't like us doing that because in here we do need to do that. It's kind of interesting though. I feel like it. Yeah. it potentially hasn't actually cleared the actual value, but it does the frame rate. But got to this point, cool. Couldn't execute this statement. I would have thought it could. I would have thought it could have. So I guess what we need to do is make some tests that are just for this. So we can have a look in this, and we have a JMP. So what we can do is we can have a test assemble of JMP 0 label, and then we can set label to be there. Maybe we can put a byte in just between, just so it kind of makes sense. And we don't actually have a notion of labels, but I would have thought that this would have kind of failed earlier. We can also do just that one test that we did, JMP0 label, DB0 label, colon, and we can get this file to file, and it's now this one. Cool. So if we get into ASM, so it couldn't get this, but I think it should be able to. And we can run it in GDB, layout, source, and we can break in ASM exec statement in here, because that's the function that is kind of failing. So here we can display what our statement is. I guess it's a none, but it's now instruction. It sounds about right. And if we kind of look into the instruction, it would probably tell us what things are. But in here, we can do a display on ins, and we can see that it is a jump, which sounds right. So we kind of go into here. I think you can make that more efficient by kind of making it an array of functions. But yeah, and so if we kind of look inside the GIMP structure, we can see here kind of what it's got going on with it. And somewhere in here it doesn't like things. So we should be able to compute the first one. And computed expression, and perhaps also bar computed expression. And then here we should be able to kind of see what's happened. So it got a none. That sounds right. It should kind of do all this stuff. It should kind of make sure it has things. Perhaps we could also output config output. I think, yeah, that'll just kind of tell us. So we can see it's got a capacity of 4, which is good. We asked it for that capacity, and now we're going to kind of print things in. And so in this, we are now wanting to output bytes, and we have the data size of a word. That sounds right. And so we kind of just output those two things, and that should kind of get back to that. We get 3. That sounds right. And I wonder if I can kind of force this to show more. I mean, on the display 7, 8, 9, and 10. All right. So if we just print out the output data. So we have that value, and like perhaps if we do that, we can see that it's EA, which is kind of what I expected. And here it's put in 0 for everything. That kind of makes sense because it was we were jumping 0, so easy. So if we can now compute this fire expression, so we should get map, we shouldn't have a value. So if we kind of look, we have no value. We now return a whole. So this should now say it's a whole. Perfect. At this point here, it's interesting that let me have that as the first statement without the brace. Interesting. So we now get the array out of this. There was no array, so we should create an array. That kind of makes sense. We put that array in. Now we have just a pointer to the array, so whatever we get out of the hash map should kind of work out to the same. And then perhaps I will display what array data 0 kind of looks like. It's null at the moment, that because data hasn't been done, but we do one thing and we can see here that it got the location of 3. So that is after the OE or whatever it was, EA, and then it was after 2 bytes, specifying the 0, and now we're at this byte, and this is our whole, and it is 3, and we're only wanting a word's worth of things. And so now we should kind of output more stuff to the output, so we should get another 2 bytes, and it'll just be more zeros. Cool. There is now 2 more bytes, and here we can see so start was 0 and expected was only 4. All right, so that's why it is about to fail. So expected equals in size. Expected plus equals in size. So this we want to do plus equals there because we have the first initial one and then we do more. And then we do this and then we, cool. We did a thing. Now we need to kind of see what the notion of a colon is. And so that is setting the label as to what it is. So, kind of interesting. Do we have a... we do have a colon, and that's kind of why we got it. When we get a colon, we only check for it. And this point, which is probably jump, yes. But when we find an identifier, we'll look for an equals. So yeah, this is when we're parsing assignment. And we don't always want to parse an assignment on identifier. So that's the thing. We have an identifier and we kind of need to get the next token to see what is this thing that you're wanting me to do. So what I need to do is actually from this, take this and do this. And then we will be switching on. So if it's not a symbol, not sure what it is. So in this case, we can perhaps kind of do nothing there, and we can return this type of thing. And expecting equals or colon after label after identify found whatever we found, and this found so this one is just token.span, and this next is going to be next. Cool. So if that's the case, now we kind of need to do a switch on next.symbol, I think I do. Yeah, and then if we have a case ASM symbol equals, then we would do all of this stuff. And because of that assignment, we probably need to do that. And do we have if dot start num symbols? We do. That kind of looks like that. It's kind of interesting just after a return. Kind of interesting. Probably I do want that, but I want that there, and then unhandled symbol type. In yeah, so this red, where does that kind of get set? Does it get set to a default? Yeah, it does get set to a default. That way, if it returns, it will return a statement none anyway, because statement none is the first entry, so it will be a 0 in the list. Just the way it is. So if we get an equals, then we get that. And so now if I kind of run that same file, it will get to this point here, like right where it was, because now we need to, interesting. We got symbol none. I kind of want to do a little debug on that just to see how it's tokenizing that whole thing. Yeah, it did get a symbol of there. It unfortunately doesn't say what symbol it is because of where it is, but yeah. Fire expression. So like we got all the way there, yeah, and then we oh, I see what it's doing. It's trying to kind of parse the label as a binary operator. No, that's fine. Yeah, so it does that DB0. Then we get white space. Interesting. Are we giving it the right symbol? Yeah, we're not giving it the right symbol here. We want next dot symbol and next dot symbol and next dot symbol. And now I hope it says colon. Yeah, so symbol colon. So we deal with that ASM symbol colon. And at this point, we do a different thing. So this is, I mean, this is kind of set and like config.out.size and that sort of thing. So label equals that, and we can kind of do an instruction for that. And then we also kind of want to look through search holes for label, then like insert at that point, which would kind of mean the ASM output bytes is currently just appending, but we would have to do a similar thing of kind of setting bytes at a point. But yeah, at that point there, we'll do that, and then you can kind of continue on. But I think that is probably where I'm going to get to now. And like if we have a look to see where it kind of gets up to, if we kind of run that, perhaps we should do an fprintf one of these first, and we can do it on next. And then we can just do to do and like maybe yank in there and do that sort of thing, and then that way it will show me in the source code where we got up to, and this will kind of confirm that we have moved past this point here, got the label. Now we've kind of parsed the label, and now we're seeing that colon, and now we kind of need a backfill. But I think that is what I have in me for today. So might add that up. It felt like a decent kind of chunk just as one thing. So I've done like kind of one half of the holes thing, but I've only actually done it in one place. So I'll have to add some more tests to kind of make it fail in the right place. You'll see I've got some other tests. I need to kind of integrate them maybe. I kind of wrote some just C style tests. But yeah, do half first of whole in JMP instruction. And that's that. And I think that's that for now. And just as a little safety thing, I'll run all my tests and see that it fails. Which, yeah, that's because we so here we kind of want to do an ASM token T next token. And here we can do this, and like where else do we use next? Just in those points. So I think I'll just change this to be next token. So it's the way the Vibe goes, and now we'll kind of complain at this point, and we can pass in that next there, and then that should hopefully pass all the tests. When I say pass all the tests, it does not. So this is all right. What was it failing on? This is other tests. So different error message, expecting equals or colon. After identifying that, found that. Perfect. So that will probably now fix that message. We have another hole. So I wonder, I might just kind of note to do message, and this depends on more of implemented, and we'll just skip that one. Right, and we haven't handled the word there now. We are in 32 bits, so this is we do set it to D word. All right, and at this point here, how do we kind of output that D word? We just do a few more things like that, and then yeah, it will be something like that, and then this will be like more, and then a couple more like that, and that does that, and this is now going to turn 4 bytes. Right, that I think I'll leave that and kind of get the test working another point, because yeah, the output function doesn't quite work. But yeah, that is that, and I hope that's of enjoyment to some people. And until next time, I'll see you.